Welcome, ladies and gentlemen. This is Unit 2, Day 4. All right, I'm your host, Mr. Kaya, and we're going to be reviewing this unit. Yay! All right, check it out. We only got 4 days here. So this unit's very short, but there's a lot of important things in here, so we don't want to jump through a lot of this stuff. We want to make sure we take our time and have an understanding of what it is these functions are, what their compositions are when you add and subtract them, and then also we must be comfortable with the inverse, okay? So let's talk about what I'm going to do in this video. I'm going to do all of the odd problems, which means you guys are going to do all of the even problems, okay? So I'll do all the odd, you do all the even, and then we would have done all of the problems, okay? So, means I'm going to do about 8 problems here, and 8 or 9. Let's see, how many were those? 18? Okay. So we're doing about 9 problems. Okay. All right. So, problem number 1, it says if f of x is equal to x squared minus 2x plus 3, find the value of f at negative 2. So this right here, okay, that negative 2 is our input. Okay, so what they want to know is when we input this guy into our function, what kind of answers do we get? Okay, so anywhere you see an x, I stick that negative 2. Okay, and so I get 4. This one gives me a plus 4 plus 3, and our answer is 11. So f at negative 2 is 11, is how you would interpret that. All right, so when our input is negative 2, our output is 11. Okay, take a look at number 3. Okay, if h of x is equal to 3 halves x minus 4, find the inverse. Okay, so find h inverse when our input is negative 6. Okay, so this is the inverse function. Okay, and that's our input. So we got a couple steps here. All right, so first we're going to have to find what the inverse of this function is, and then secondly, we're going to have to plug in that negative 6 to find out what the h of inverse negative 6 is equal to. Okay, so first, remember h of x is just a fancy way of saying y. So I'm going to take the y, whoops, write it right here, minus 4. Okay, and then now I'm going to switch my x and y, and then solve for y. Okay, so my first step is to add 4. So I get x plus 4 is equal to 3 halves y. I'm going to multiply by its multiplicative inverse. Cancels over here. And so my answer is y is equal to 2/3 x plus 4. Okay? And it doesn't tell us to leave it in any specific form, so that one's good. And so let me finally change it. So it's going to be f of negative 1 of x is equal to 2/3 x plus 4. Okay? Great. All right. Now, we're not done here yet. Actually, this is h. Sorry. h of x. h inverse of x. All right. And so now that we have the inverse function, now I can take my input here, which is negative 6, and I substitute it in for the x. Okay? And so we're going to have h negative 1 of negative 6 is equal to 2/3 times negative 6 plus 4. Okay, so add those two together, I get 2/3 times a negative 2. I'm going to write that over 1. And so now I just multiply across. Okay, so I get a negative 4/3. Okay, so when our input for our inverse of h function is -6. Our output is -4/3. Okay, that's our answer. All right, let's keep going. Number 5. All right, if f of x is equal to 3x minus 4, g of x is equal to x squared, find the value of f at 3 minus g of 2. Okay, so we haven't really quite covered this one yet. All right, but process is pretty much the same. So if we just had, beforehand, we were doing stuff like this, f of x minus g of x, right? And so all we had to do was we had to write 3x minus 4, okay, minus x squared. Okay? So, in order to do this guy right here, right, we would have to find when our input for our f function is 3 and when our input of our g function is 2, okay, what is our output for those? All right? So, let's find out what f of 3 is. Okay, so f of 3, let me erase all this stuff here, okay? So f of 3 is equal to, okay, 3 times 3 minus 4, which is 9 minus 4, which is 5, okay? G of 2 is equal to 2 squared, which is equal to 4. And so now, to finally finish this off, I'm just going to substitute these values in for our f at 3 and our g at 2, okay? So we come back down here. So f of 3 minus g, our input is 2. And I just switch that out. So f of 3 is 5, g of 2 is 4, and our answer is 1. Okay, let's move on to number 7. So number 7 says which function is not one-to-one? Okay, so what does it mean by not one-to-one? We are looking for repeated y values, right? Okay, looking for repeated y values. So let's take a look at the first one. Okay, looks like it's a function, no repeating x's, no repeating y's, so it's not number 1. Number 2, I see no repeating x's, I see no repeating y's, and so that guy's good. This one, let's see, no repeating x's, no repeating y's. Finally, oh, look at these guys right here. Okay, we got no repeating x's, but we do have repeating y's. So our answer is 4. All right, let's keep going. Which graph represents a function, or represents a relation that is not a function? Okay. Well, what we were looking for is we're looking for when we draw a vertical line, whether or not we're hitting the graph twice. Now this one looks kind of close, but it's gradually going closer to 0. So this one's not it, okay? This guy, okay, we're not hitting the graph twice. So that guy's not it. Whoops. All right, 1, 2, okay. Just making sure I'm crossing off the right ones. All right. Now this guy, right, even though it's got a hole there, right, this is still a function. All right. This one is not. Okay, so 3 is the answer because if you draw a vertical line here, I'm running into our graph twice. So this is a step function, but as you can see the difference between this guy here and this guy here is that this one down here actually has holes in it, right? So when you draw a line up here, we're just going through that hole there. Okay, so our answer is 3. And just to be a little more clear, I'm just going to circle the right graph. Put it in pink. And there we be. All right, so that's number 9. Number 11, is the following function one-to-one? Explain your answer. Okay, so again, we're looking for repeated y values. Okay, and so as you can see, right, it's still a function, right, because we don't have any repeated x's, but if you notice, 1 and -1 both go to 5. And so repeated y values, so therefore, this is not a one-to-one function. Let's keep going. Let's go down to 13. 13. Okay? Now, this one looks different than a lot of the other ones we talked about in class because this one actually is associated with some sort of word problem here, right? We got distance hikers traveling, and then we have the elevation of where they're hiking at. Okay? And so that makes a difference, right? Because when you're hiking uphill, right? If you think about it, I mean, you're still going that distance, but if you were to look on a map, you wouldn't be going very far, either to, north, south, east, or west, right? Because you're actually going up in elevation. So your distance, you're still walking a large amount, or the same amount, but you're not going, as far as if you were to be walking on straight land, right? Or straight ground. So anyway, going back to that. So in this problem right here, anytime, and the reason why I'm bringing that up is anytime you are associated with some sort of word problem, when you have a picture of a graph here, and we're talking about taking data from it, okay? These two endpoints is where our graph stops, okay? This is a type of graph that doesn't go on forever because, right, well, it wouldn't really make sense, right? Because the distance the hikers are traveling, they just keep walking forever. No. And also, you just got to remember that it's a word problem, okay? This stuff that's graphed is actually probably real data points, right? And so, therefore, this graph just doesn't go on forever, okay? So just remember that anytime there's any sort of words or some sort of word problem associated with the graph, we have to take into account that it does not go on forever, okay? So state the domain and range in interval notation. Okay, so our domain, as we go left to right, as you can see, we are starting at 0, and we stop at 12. Okay, and again, those both go in brackets because we want to include both of those values. And then our range looks like we go from the bottoms up. Okay, the first y value we hit is 1,000. And then our last y value we hit is on this line right here. So it looks like it's 1,500. And again, that goes in both brackets because we want to include those values. Oh, yeah, interval notation, sorry. Because I was like, I got down to this one, I was like, state the domain and range. I was like, I did, as an equality. Okay, we can do that. Okay, let's make sure, hopefully Mr. K gets it right this time, right? So 0 is less than or equal to x, which is less than or equal to 12, okay? I want to include that line underneath because I want the reader to know that I'm including 0 and 12 as these data points, okay? If I didn't want to include them, I would put them in parentheses. Now, for our range is going to go from 1,000 less than or equal to y less than or equal to 1,500. Okay, so is this a function? Yes. Okay, would its inverse be a function? No, because it is not 1-to-1. Okay? All right, let's go down to 15. The accompanying tables define functions f and g. So in this one it says find f4 minus g of 6. Okay, so f of 4, right, what this is talking about is when our input is 4, whoops, when our input is 4, what is our output? Okay, same thing for the g. When our input is 6, what is our output? So I'll highlight that in red. So our output for f of 4 is 6 minus, and then g of 6, when our input is 6, our output is 10. So 6 minus 10 is a negative 4. All right, let's move down to 17, and then the rest is for you guys to try on your own. All right, so if the graph of the equation y equals 2x is reflected in the line y equals x, the equation of the image is. Okay, so remember when we're doing inverse, okay, what's happening in the graph of our picture is it's actually reflecting over this line y equals x. So inverse the graph of inverse functions reflect over the line y equals x. Okay? So, that being said, right, what we're trying to find here then, right, the equation of its image, right, what it's saying is find the inverse function, right? The graph of the equation y equals 2x is reflected over the line y equals x. The equation of the image is what? Okay, whoops. So we're finding the inverse of this function. So I write it down here. Okay, switch my x and y's, and then solve. So I divide by 2, and y is equal to x over 2. Turn it back into, well, actually we're going to leave it like this, right, because they're all y equals. And so do we see that? We sure do. Okay? So there's number 17. And so that leaves you guys 1, 2, 3, 4, 5, 6, 7, 8 problems. Or 9, right? It should be 9 somewhere. Anyway, somewhere there, 8 or 9. All right? So the rest is for you guys to try for homework. Also, you can see the answer key down here. Okay? So just keep that in mind. You can also use this as a reference to check your answers. Or check my answers, right? Maybe I got one wrong here. So anyway, that's for me to know and you to find out. So good luck, you guys. The rest is for homework, and here you be.